Have you ever actually stopped to think about the air you're breathing right now? I mean, not just what's in it, but who designed it. Because that feeling of comfort you have in a room, well, that's no accident. It's a huge, invisible system working behind the scenes. And that system is HVAC. You know exactly what I'm talking about, right? You walk into a building on a scorching hot day, or when it's freezing outside, and the air inside is just perfect. It's not too hot, not too cold. It feels fresh. It just feels right. So how in the world does that happen?
Well, that feeling has nothing to do with magic. It's all about some seriously meticulous engineering. It's the end product of a system that's designed to control your environment right down to the degree. It's heating, ventilation, and air conditioning, or as we all know it, HVAC. Okay, let's dive into this hidden world.
So, here's what we're going to cover. First, we'll explore what this invisible comfort machine is really trying to do. Then, we'll decode what HV and AC actually mean. We'll also meet the people who write the rulebook for all this and the engineers who bring it all to life. And finally, we'll trace the whole process, all the way from a simple idea to a fully functioning system. All right, so what's the big picture here? What's the goal? At its core, every single HVAC system out there is trying to solve two really big problems: keeping you comfortable and keeping you healthy. It's this incredible balancing act between the temperature, the humidity, and the actual quality of the air you're breathing. And this isn't just a matter of what feels good to you or me. This is a science. There's an organization called ASHRAE. They're basically the global authority on this stuff, and they figured out the exact conditions for human comfort. You can see how the ideal temperature range actually changes a bit from winter to summer. But look, it's not just about temperature. That humidity number is so important. If it gets too dry, you get that annoying static electricity and dry skin. Too humid, and you just feel sticky and gross. Getting that balance right is everything. Okay, so let's break down the acronym itself. We throw the word HVAC around like it's one single thing, but it's really three different systems, all working together as a team to create that perfect indoor space. First up, we've got the H for heating. This is the part of the system that fights back against that winter chill. You know, when your furnace kicks on and sends that wonderful warm air through the vents on a freezing day. It's pretty much the most basic and a lot of times the most critical function of HVAC, just adding heat to a space to keep us from freezing. Next is V for ventilation. This is where the fresh air comes from, and this is super important. Ventilation is not just about blowing air around. It's about strategically pulling in fresh air from the outside to bring in oxygen and push out all the stale air, pollutants, and weird smells. Seriously, without good ventilation, a building gets gross and unhealthy really fast. And finally, AC for air conditioning. Now, a lot of people think this just means making things cold, but it's way more than that. The real job of AC is to remove two things: heat and moisture. And that second one, moisture, is the real game changer. On a hot, sticky summer day, it's the AC's ability to literally pull water out of the air that makes you feel so much better. Now, with all these complex systems controlling the very air we breathe, you gotta wonder, who's in charge here? Who makes the rules to make sure all this equipment is safe, efficient, and that it actually all works together? Yeah, it is definitely not the Wild West. There's this whole global network of organizations that create the standards and codes for every little piece of HVAC. You could call them the unsung heroes of the industry. They're the ones who make sure these complex systems are safe, that they don't waste a ton of energy, and that a part made in one country will actually work with a part made in another. So let's look at some of the big players. ASHRAE is kind of the head honcho. They're like the scientists of the HVAC world, giving everyone the core data and standards. Then you got SMACNA. They're the experts on the physical stuff, like the ductwork, the actual highways the air travels on. LEED is like the environmental conscience, always pushing for greener, more efficient buildings. And NEMA makes sure all the electrical parts are safe and work together without any problems. So we have the science and we have the rule books. But who is the person that actually puts all of these puzzle pieces together? Well, let's meet the architect of the air, the HVAC design engineer. To put it simply, the design engineer is the one who looks at a static building blueprint and figures out how to make it a living, breathing system. They are the masterminds who design the entire heating and cooling network, from the gigantic chillers on the roof all the way down to the tiny thermostat on your wall. And they have to wear a bunch of different hats to get the job done. They have to be an analyst, crunching all the numbers to figure out exactly how much heating and cooling a building is going to need. They're also a drafter, turning those numbers into detailed plans for all the ductwork and piping.
And they absolutely have to be a collaborator, working hand in hand with architects and construction crews to make sure their brilliant design can actually be built in the real world.
And that brings us to the last leg of our journey. How does an HVAC system actually go from just an idea to a real working thing? Well, it's a very precise, step-by-step process. It's all about a logical flow. First, you have to completely understand the building, its size, what it's made of, even which direction the sun hits it from. That's the survey. From there, you can choose the right kind of system for that specific job. Then comes the really critical part, the load calculation. That's all the math to figure out the exact amount of heating and cooling power you're going to need. Only then can you actually pick the right equipment. Once you have your machines, you design the distribution network, the roadways for the air. And finally, you put it all together in one master plan that shows where every single piece of the puzzle goes. So the next time you walk into a room and feel that perfect indoor climate, just take a second to appreciate that invisible architecture that's all around you. That simple feeling of comfort is actually the result of this massive effort of science, engineering, and incredibly detailed design. And this all leads to a really cool question for the future. If we can already design the temperature and humidity of our air, what's next? Could we one day design air that makes us more productive or more creative, maybe even healthier? As our technology gets smarter and smarter, the very air we breathe might just be the next great frontier in how we design our buildings.